Okay, so we're going to have a look at another question from the topic of electromagnetism. So here we're asked what magnitude and direction of magnetic field is necessary to balance the gravitational force on an electron moving horizontally north at 100 meters a second. Okay, so this is a very strangely worded question. We're going to assume that what is meant is an electron is moving north. So this way, we're going to say that this is north. So when we say horizontally north, we're meaning towards the North Pole. So this is the surface of the Earth. This electron is heading towards the North Pole. We're told its velocity is 100 meters per second. It's 100 meters per second. Now we're going to assume that it has a gravitational force on it pulling down. So this is the force due to gravity. This is mass times gravity. We need to work out what kind of field is required here to make the magnetic field force equal to the force due to gravity. So we need F of B to be equal to mg. Now we know that the force due to a magnetic field is equal to the charge of the particle multiplied by its velocity multiplied by the field strength. Now we are going to assume that it is at a 90-degree angle, so we have no sine of theta. So this is the force due to the field, and this is going to be equal to the force due to gravity, which is mass times gravity. And then they're asking us what is the magnitude and direction of the magnetic field. So we need to solve this for B. This tells us that the field is equal to mg over qv. Now mass of an electron is 9.1 times 10 to the minus 31 multiplied by g. We're going to say that's minus 9.8 divided by the charge in the electron, which is minus 1.6 times 10 to the minus 19 times the initial velocity, which is 100. So this tells us that the value of the magnetic field, it's going to be the strength of the magnetic field, 9.1 times 10 to the minus 31 times minus 9.8. The calculation part of this question is the easiest part. The hardest part is determining the direction, which we'll do in a moment, times 100. So my calculator tells me that this is 5.5737 times 10 to the minus 13. And this will be in Teslas. So this is the magnitude of the field. Now, if this was a proton and it was traveling this way, if the field was going into the page, the acceleration would be upwards, because we would have the velocity vector going this way. If we use our right hand rule, our index finger would point in that direction, our middle finger would point into the page, which would be the field direction. That would mean the force due to the field would be up. That's if it was a proton. If it's an electron, it's the opposite. So it'll be down. So if the magnetic field goes into the page, that will apply a downwards force on the electron. So we need the force to come out of the page. So this is out of page. In our working here, this means the field is heading towards us. Right? It's heading through the page or through the screen towards us, and this is its magnitude. This is a very strangely worded question.